Hello learners. Today we will be discussing about arithmetic progression. So a progression or a sequence is said to be arithmetic progression, that is AP. The abbreviated form of arithmetic progression is AP. Okay? So a sequence of numbers are called arithmetic progression when each number of the sequence is at a common difference from preceding number. Now let us take one example. If we take the example of counting numbers like 1, 2, 3, 4, 5, 6, and so on, we will find that the number 2 is at a common difference of 1 from its preceding number, that is 1. Again, number 3 is at a common difference of 1 from its preceding number, that is 2. And this sequence will continue throughout the same. So we can say that the counting numbers written over here are an example of arithmetic progression. Now, what are the things that we checked while considering a sequence to be an AP? We checked that the sequence that we have been given, whether it have or it does not have a common difference between its preceding numbers. That is, let us call D is the common difference. What we have called the common difference? D. So if D is the common difference, then we will find that 3 minus 2 is equals to 1, 2 minus 1 is equals to 1, and so on. Even if you subtract 6 minus 5, you are getting 1. So as we have checked the sequence above, it is giving a common difference of 1 only whenever we are subtracting two consecutive numbers. Now, if we have to generalize a equation, what we will have to do? We will have to produce one general equation for an arithmetic progression. If you are producing a general equation for arithmetic progression, there has to be some terms like first term that we are going to mention with a1. We call it to be a. Now the second term, it is represented by a plus d, that is the term and 1 times the common difference. A3 is the representation of third term, and again, if we have to write the general equation of A3, we will have to write a plus 2d. So what we can observe here is that if you are supposed to write nth term of an AP, you will be having an equation of a plus n minus 1 into d. See, when we were writing the first term, we wrote it as a, that you can also say as a plus 0d, 0 times d. Now when you were writing the second term a2, you had to add d for the first time. While you are writing the third term a3, you had to add 2d to a. And so when you will have to write an, you will have to add n minus 1 times of d to the first term. So from here we have produced a general equation for arithmetic progression. And this general equation says that nth term of an AP is equals to an is equals to a plus n minus 1 into d. So we have successfully derived the equation that can help us reach to the nth term value of an AP. Now to recall the things that we have learned right now, you can say a1 is equals to a2 is equals to a plus d, a3 is equals to a plus 2d, a4 is equals to a plus 3d, and so on. Now let us take an example. Suppose there is 5 on the first position, then you have a vacant space at second position, third position, fourth position, and on the fifth position as well. Now on the sixth position you have 22.5. And if someone questions you what are the missing terms, you are questioned to answer what are the missing terms. So how you are going to answer this question? We can solve this question using the general equation. But we will first try to solve this equation without using the general equation. We will only be using the basic equations. For example, we will consider 5 as equals to a. Then the second number will be a plus d. The third number will be a plus 2d. Fourth number will be a plus 3d, and fifth number will be a plus 4d. And this is how we can say that the last number of this sequence, that is given as 22.5, will be equal to a plus 5d. Now what you can do, you can simply use these two values to produce an equation. Our first equation is a is equals to 5, and our second equation is a plus 5d is equals to 22.5. Now solving these two equations, that is putting the value of a as 5 in the second equation, you will get 5 plus 5d is equals to 22.5, and d is equals to 22.5 minus 5 divided by 5, and that will be equal to 17.5 divided by 5 equals to 3.5. So what we have got? We have got the common difference. And as soon as we have got the common difference, we have almost completed this question, because the sequence that was to be completed by us was 5, 3, 4, 5, first term, second term, third term, fourth term, fifth term, and sixth term was given, that is 22.5. Now we simply have to add d to the first term. So 5 plus 3.5, that is a plus d, is equals to 8.5. So the second term is 8.5. A plus 2d is equals to 12. So the third term is 12. A plus 3d is equals to 15.5. So 15.5, and then a plus 4d is equals to 19. That is 19. Now to check whether we have solved this equation correctly or not, what we have to do? We have to add 3.5 to 19 and check for our answer to be equal to 22.5, and that we can see is the right answer. So from this example, what we have observed is that even without knowing the general equation that we have just derived, that is an is equals to a plus n minus 1 into d, we can easily solve an arithmetic progression for its nth term or any term that is unknown to us. In this question, you can see there are four terms which were unknown to us. We were only knowing the first term and the we were only knowing the first term and the last term. And using our knowledge of basic equations, we solve this question.